Lesson 15.2 is find the definite integral of rational functions. And rational functions are just fractions where x is in the denominator. And so the basic one is 1 over x. This is called the reciprocal function. It's got a parent poster on my wall. And here's the graph of it as well. I put it in blue. So it makes these two curves, one in quadrant 1 and one in quadrant 3. Well, the antiderivative or the integral of that is natural log of the absolute value of x. And why it needs absolute value around x is because natural log of x is actually just this. And so that doesn't cover the whole domain because rational functions should really be everywhere except for x is 0. So if I make it the absolute value of x, then it actually takes this ln function and reflects it over the y-axis where it's reflecting the x values from positive to negative. So it just kind of helps me visualize why it is what it is, that it has to be absolute value of x to actually cover the whole domain of rational functions. Same thing's going to apply where anytime there's something times x, the antiderivative or the integral tells us to divide by that number or multiply by the reciprocal. So it's like the backwards chain rule. So let's just try one. It says find the value from 3 to 5 of the area under the curve of 3 dx over x minus 2. The other tricky part, it's going to want us to express our answer as a certain way. In this case, as a constant times natural log of 3. So I have to have natural log of 3, and I'll have to manipulate the logs to get them to be the way I want. But first off, I really don't like how this looks. So let's change this. So that's the integral, 3 to 5. And I'm going to put 3 over x minus 2 times dx. I don't like the dx being on top. Then what I would do is I always want the numerator to be 1. So I'm going to factor out the 3. So I have 3 times the integral 3 to 5 of 1 over x minus 2 dx. So as soon as I see this fraction, I know that when I integrate it, it's going to be times the natural log of the absolute value of the denominator x minus 2. Nothing is getting multiplied by x, so I don't need to divide by anything other than 1, which won't change it. And then I want to put my bounds. I'm going to do a bracket here to not get confused with my absolute value bar from 3 to 5. Okay, so now when I go to simplify, I've got 3 times, I'm going to do parentheses, ln. I'm going to plug in my 5 minus 2 minus ln of 3 minus 2. That would give me 3 times ln of 3 minus ln of 1. Remember what ln of 1 means. Natural logs have a base of e. They're saying e to what power would make 1? Oh, I meant to put a question mark. I already gave the answer. E to what power would make 1? Well, it has to be 0. So ln of 1 is really 0. So I actually just have 3 natural log of 3. So actually I don't have to manipulate this at all. I have natural log of 3. It's 3 times natural log of 3. Let's try another one. I'm going to rewrite this again so that I have the integral 1 to 7 of 2 over 4x minus 1 dx. I'm going to take out the 2 so that I have the numerator of 1 that I want over 4x minus 1 dx. So then when I integrate that, I get 2 times natural log of the absolute value of 4x minus 1. But because there's a 4 times x, I have to divide by 4 or times 1 over 4. And I want this to be from 1 to 7. So 1/4 times 2 is 2/4 or a half times natural log of the absolute value of 4 times 7, which is 28. 28 minus 1 is 27. Minus natural log of plug in 1. 4 times 1 is 4, minus 1 is 3. Which is just natural log of 27 minus natural log of, I cannot write, 3. Okay, so our properties of logs. Whenever I have subtraction between two logs that have the same base, I can put them together with division. So I actually have 1/2 times natural log of 27 divided by 3, which is 9. Okay, but they don't want anything in front of the natural log. So any multiplication actually can get put as a power. 9 to the 1/2 power really means square root of 9, which is 3. So I have natural log of 3. That's my answer. Then number 3, this one has different wording, so be aware. Find the average value of the function from 1 to 6. Express your answer as a constant times natural log of 3. So we want to then think, how do I find the average value? Well, I'm going to integrate the function, which gives me y values. And I want it from 1 to 6, but I have to divide it by my b minus a, because average means you're dividing by the number of numbers. And so then I'm going to integrate this. I'm going to take out my 10, and then I know that's going to be a 1 over 3 minus 8x, so I'll have times natural log of the absolute value of 3 minus 8x, but I have to divide by negative 8, or times negative 1 over 8, divided by 6 minus 1 is 5, and I want to find that from 1 to 6. So then I've got negative 1/8 times 10 would be negative 10/8, or negative 5/4, times natural log of the absolute value of 3 minus 8x, 1/6. Dividing by 5 means I can multiply by 1/5, and actually my 5s would cancel, so I get negative 1/4. That would be, plug in 6, 3 minus 48 is negative 45, but because it's an absolute value, will become positive. Minus, natural log, plug in 1, 3 minus 8 is negative 5, but absolute value makes it positive 5, because we cannot do logs with negative numbers. Okay, and so then I have subtraction between the logs, so I'm going to put them together by taking 45 divided by 5, which is 9. But I don't want 9. They want me to manipulate this so that it's a 3. So how could I rewrite 9 using an exponent? It would be 3 squared. And then I want to take this power, bring it to the front with multiplication. So this power and this coefficient, they can go back and forth with either makes it a power or it makes it multiplication. So that would be negative 2 times negative 1/4. Natural log of 3. 2/4 is 1/2, and it would be positive. So it's 1/2 times natural log of 3. And that would be, oh, I didn't mean to have a negative there. Sorry. So that should be actually a negative 1/2 times natural log of 3.